that are interested in what we've got to say. And 3, 2, 1, we are live, baby. This is it.
Yeah.
Welcome back to another Vector Space Talks. I'm here with my man Diptanu. He is the founder and creator of Tensorlake. They are building Indexify, an open source, scalable, structured extraction engine for unstructured data to build near real time knowledge bases for AI agent driven workflows and query engines. And if it sounds like I just threw every buzzword in the book into that sentence, you can go ahead and say bingo. We are here and we're about to dissect what all that means in the next 30 minutes. So, dude, first of all, I got to just let everyone know who is here that you are a bit of a hard hitter. You've got some track record under your, some notches on your belt, we could say, before you created Tensorlake. Let's just let people know that you were at HashiCorp. You created the Nomad cluster scheduler, and you were the inventor of Titus cluster scheduler at Netflix. You led the FB Learner machine learning platform and built real-time speech inference engine at Facebook. You may be one of the most decorated people we've had on and that I have had the pleasure of talking to. And that's saying a lot. I've talked to a lot of people in my day. So I want to dig in, man. First question I've got for you. It's a big one. What the hell do you mean by AI agent driven workflows? Are you talking autonomous agents? Are you talking like the voice agents? What's that?
Yeah, I was going to say that what a year the last couple of what a last great last couple of years has been for AI. I mean, in context learning has kind of like changed the way people do models and access models and use models in production. Like at Facebook in 2017, when I started doing machine learning, it would take us 6 months to ship a good model in production. And here we are today in January 2024. New models are coming out every week, and people are putting them in production. It's a little bit of a YOLO where we don't like. I feel like people have stopped measuring like how well models are doing and just ship in production. But here we are. But I think underpinning all of this is kind of like this whole idea that models are capable of reasoning over data and non-parametric knowledge to a certain extent.
Mm,
And what we are seeing now is, workflows stop being completely heuristics driven, or as people say, like software 1.0 driven. And, people are putting models in the picture where models are reacting to data that a workflow is, seeing. And then people are using models behavior on the data and kind of like making the model decide what should the workflow do. And I think that's pretty much like to me what an agent is. And an agent responds to information uh, of the world, and information which is external, and kind of like reacts to the information, and kind of like orchestrates some kind of like business process, or um, some kind of like workflow, some kind of decision making in a workflow. That's what I mean by agents. And they can be like autonomous, they can be, you know like something that writes an email, or writes a chat message or something like that. The spectrum is wide here.
excellent. Excellent. So, next question, logical question is, and I will second what you're saying, like the advances that we've seen in the last year. Wow. And the times are a changing. We are trying to evaluate while in production, and I like the term, yeah, we just YOLO'd it, or as the young kids say now, or so I've heard because I'm not one of them, but we just do it for the plot. So we are getting those models out there. We're seeing if they work, and I imagine you saw some funny quotes from like the Chevrolet chatbot that it was asked on it was a chatbot on the Chevrolet like support page, and it was asked if Teslas are better than Chevys, and it said, yeah, Teslas are better than Chevys. So, yep, that's what we do these days. This is 2024, baby. We just put it out there and test and prod. Anyway, getting
Yeah,
back on topic, let's talk about Indexify because there was a
yeah.
whole lot of jargon that I said of what you do. Give me the straight shooting answer. Break it down for me like I was five.
Yeah. So if you are building an agent today, which depends on augmented generation, like retrieval augmented generation, and given that this is Quadrant's show, I'm assuming people are very much familiar with RAG and augmented generation. So, if people are building applications where the data is external or non-parametric, and the model needs to see updated information all the time, because let's say like the documents under the hood that the application is using for its knowledge base is changing, or like someone is building a chat application where new chat messages are coming like all the time, and the agent or the model needs to know about what is happening. Then you need like a index or a set of indexes which are continuously updated, and you also, over a period of time, you want to extract new information out of existing data, because models are getting better continuously.
Hmm.
And the other thing is, AI until now, or until like couple of years back, used to be very domain like oriented or task oriented, where modality was like the key behind models. Now we are entering into a world where information being encoded in like any form, like like documents, videos, or whatever, like are important to like these workflows that people are building, or these agents that people are building. And so you need like capability to ingest any kind of data, and then build indexes out of them. And indexes, in my opinion, are not just embedding indexes. They could be indexes of like semi-structured data. So like let's say like you have an invoice, you want to maybe like transform that invoice into like semi-structured data of like where the invoice is coming from, or like what are the line items and so on. So in a nutshell, right, you need like good data infrastructure to store like these indexes and serve these indexes. And also you need a scalable compute engine, so that whenever new data comes in, like you're able to like index them appropriately and update the indexes and so on. And also you need capability to experiment, to add new extractors into like your platform, add new models into your platform, and so on. Indexify helps you with all that, right?
Hmm.
So Indexify, imagine Indexify to be an online service with an API, so that developers can upload any form of unstructured data, and then a bunch of extractors run in parallel on the cluster and extract information out of this unstructured data, and then update indexes on something like Qdrant or Postgres for semi-structured data continuously,
Okay.
right? And you basically get that in a single application, in a single binary, which is distributed on your cluster. You wouldn't have any external dependencies other than storage systems, essentially, to have a very scalable data infrastructure for your RAG applications or for your LLM agents.
Excellent. So then talk to me about the inspiration for creating this. What was it that you saw that gave you that spark of, you know what? There needs to be something on the market that can handle this.
Yeah. Earlier this year, I was working with founder of like a generative AI startup here. I was looking at what they were doing. I was helping them out, and I saw that, and then I looked around. I looked around like at what is happening. Not earlier this year, as in like in 2023, somewhere in early 2023.
Uh-huh.
I was looking at like how developers are building applications with LLMs, and we are in the golden age of demos, golden age of demos with LLMs. Like almost
That is the truth.
anyone, I think, with some programming knowledge can kind of like write a demo with an OpenAI API, or, with an embedding model and so on. And, I mostly saw that the data infrastructure part of like those demos or those applications were very like, very basic. People would do like one shot transformation of data, build indexes, and then, do stuff, right? Build an application on top. And then I started talking to like early adopters of RAG and LLMs in enterprises, and I started talking to them about how they're building their data pipelines and their data infrastructure for LLMs.
Hmm.
And I feel like people were mostly excited about the application layer, right? A very less amount of thought was being put on the data infrastructure. and it was almost like built out of duct tape, right? Of pipeline, like pipelines and workflows like RabbitMQ, like X, Y, and Z, very bespoke pipelines, which are good at one-shot transformation of data. So you put in some documents on a queue, and then somehow like the documents get embedded and put into like something like Qdrant. But but there was no like thought about how do you reindex. How do you add a new capability into like your pipeline, or how do you keep the whole system online, right? Keep the indexes online while reindexing and so on. And so classically, if you talk to like a distributed systems engineer, they would be like, oh, like this is a map reduce problem, right? So there are tools like Spark, there are tools like Anyscale's Ray, and they would classically like solve these problems, right?
Yeah.
And if you go to Facebook, we use Spark like for something like this, or like Presto, or like we have a ton of like big data infrastructure for handling things like this. And I thought that, in 2023, we need like a better abstraction for doing something like this. The world is moving towards serverless, right? Developers understand functions. Developer thinks about compute as functions, and functions which are distributed on the cluster and can transform content into something that LLMs can consume. And that was the inspiration. I was thinking, what would it look like if we redid Spark or Ray for generative AI in 2023? How can we make it so easy so that developers can write functions to like extract content out of any form of unstructured data, right? You don't need to think about text, audio, video, or whatever. You write a function which can kind of like handle a particular data type and then extract something out of it. And now how can we scale it? How can we give developers very transparently like all the abilities to manage indexes and serve indexes in production? And so that was the inspiration for it. Like I wanted to reimagine MapReduce for generative AI.
Wow. I like the vision. You sent me over some ideas of different use cases that
Yeah.
we can walk through, and I'd love to go through that and put it into actual tangible things that you've been seeing out there and how you can plug it in to these different use cases. I think the first one that I wanted to look at was building a co-pilot for call center agents and what that actually looks like in practice.
Yeah. So I took that example because that was like super close to my heart, in the sense that we have a design partner like who is doing this, and you will see that in a call center, the information that comes into a call center, or the information that an agent in a human being in a call center works with, is very rich. In a call center, like you have phone calls coming in, you have chat messages coming in, you have emails going on, and then there are also like documents like which are knowledge bases for human beings to answer questions or make decisions on, right? And so they're working with a lot of data, and then they're always like pulling up a lot of information. And so one of our design partners is like building a co-pilot, right, for call centers essentially. And what they're doing is, they want the humans in a call center to answer questions really easily based on the context of a conversation or a call that is happening with one of their users, or pull up to date information about the policies of the company and so on. And so the way they are using Indexify is that they ingest all the content, like the raw content that is coming in, video, not video actually, like audio, emails, chat messages, like into Indexify. And then they have a bunch of extractors like which handle different type of modalities, right? Some extractors like extract information out of emails, like they would do email classification, they would do embedding of emails, they would do like entity extraction from emails. And so they are creating many different types of indexes from emails. Same with like speech, right? Like data that is coming on through calls, like they would transcribe them first using a ASR extractor. And from there on, like, the speech would be embedded, and, the whole pipeline for like a text would be invoked into it. And then, the speech would be searchable. Like, if someone wants to find out what conversation has happened, like, they would be able to look up things. There is a summarizer extractor, like, which is like looking at like phone call and then summarizing like what the customer had called and so on. So they are basically building a near real time knowledge base of one, what is happening in with the customer, and also they are pulling in information from their documents. So that's like one classic use case. Now they are not the only dependency now they have is essentially like a blob storage system and like serving infrastructure for indexes, like in this case like Qdrant and Postgres. And they have a bunch of extractors that they have written in-house and some extractors that we have written. They're using them out of the box, and they can scale the system to as much as they need. And it's kind of like giving them a high level abstraction of building indexes and using them in LLMs.
So I really like this idea of how you have the unstructured and you have the semi-structured and how those play together almost.
Yeah,
And
yeah,
it's like I think one thing that is very clear is how you've got the transcripts, you've got the embeddings that you're doing, but then you've also got documents that are very structured. And
yeah.
maybe it's from the last call, and it's like in some kind of a database. And I imagine we could say whatever Salesforce. It's in a Salesforce, and you've got it all there. And so there is some structure to that data, and now you want to be able to plug into all of that, and you want to be able to, especially in this use case, it's the call center agents, human agents, need to make decisions, and they need to make decisions fast, right? So the real time aspect really plays a part of that. You
Exactly.
can't have it be something that it'll get back to you in 30 seconds, or maybe 30 seconds is okay, but really it's the less time the better. And so traditionally when I think about using LLMs, I kind of take real time off the table. Have you have you had luck with like making it more real time?
Yeah, so there are two aspects of it. How quickly can your indexes be updated? As of last night, we can index all of Wikipedia under 5 minutes on AWS. We can run up to like 5,000 extractors, like with Indexify concurrently and parallelly. And so I feel like we got the indexing part covered, unless like obviously like you are using a model as behind an API where we don't have any control. But assuming like you're using some kind of embedding model that, or like some kind of like extractor model, right, like a named entity extractor or and speech to text model like that you control and you understand the IOPS, like we can scale it out, and our system can kind of like handle the scale of getting it indexed like really quickly. Now on the generation side, there are, that's where like it's a little bit more nuanced, right? Generation depends on how big the generation model is. If you're using GPT-4, then obviously like you would be playing with like the latency budgets that OpenAI provides. If you're using like some other form of models like Mixtral, MOE or something, which is very optimized, and you have worked on making the model optimized, then obviously like you can cut it down. So it depends on the end-to-end stack. Like it's not like a single piece of software. Like it's not like a monolithic piece of software. So it depends on a lot of different factors. But I can confidently claim that we have gotten the indexing side of real-time aspects like covered. As long as like the models people are using are reasonable and they have enough compute in their cluster.
Yeah. Okay. Now, talking again about the idea of rethinking the developer experience with this
Yeah,
and almost reimagining what Spark would be if it were created today,
exactly.
how do you think that there are manifestations in what you've built that play off of things that could only happen because you created it today as opposed to even 2 years ago?
Yeah, yeah. So I think for example, take Spark, right? Spark was born out of big data. Like the 2011-12 era of big data. In fact, I was one of the committers on Apache Mesos, the cluster
Oh,
scheduler that Spark used for a long time. And then when I was at HashiCorp, we tried to contribute support for Nomad in Spark. And so what I'm trying to say is that Spark is a task scheduler, at the end of the day, and it uses an underlying scheduler. So the teams that manage Spark today or any other similar tools, they have like tens or 15 people, or they're using like a hosted solution, which is super complex to like manage, right? Like a Spark cluster is not easy to manage. And I'm not taking, I'm not saying it's a bad thing or whatever. It's, software written at any given point in time reflect the world in which like it was born.
Yeah.
And so obviously like it's from that era of systems engineering and so on. And since then, like, systems engineering has progressed quite a lot. I feel like we have learned how to make software which is scalable but yet like simpler to understand and to operate and so on. And the other big thing in Spark that I feel like is missing, or any skills ray, is that they are not natively integrated into the data stack, right? They don't have an opinion on what the data stack is. They are like excellent map reduce systems, and then the data stuff is like layered on top. And to a certain extent, that has allowed them to generalize to like so many different use cases. Like, people use Spark for everything.
Yeah.
At Facebook, I was using Spark for batch transcoding of speech to text for various use cases, um, with a lot of issues under the hood, right? So they are tied to like the big data storage infrastructure. So when I am reimagining Spark, I almost take the position that we are going to use blob storage for ingestion and writing raw data, and we will have low latency serving infrastructure in the form of something like Postgres, or something like ClickHouse or something, for serving like structured data or semi-structured data. And then we have something like Qdrant, like, which is very specific, very geared towards like doing vector search and so on. And so we understand like the shape of like the storage system. Now we understand that developers want to integrate with them. We understand, so now we can control like the compute layer, such that the compute layer is optimized for doing the compute and producing data such that they can be written in those data stores, right? So we understand the IOPS, right? The IO, what is it called? The IO characteristics of the underlying storage system really well. And we understand that the use case is that people want to consume those data in LLMs, right? So we can make design decisions such that like how we write into the storage system, how we serve very specifically for LLMs. That I feel like a developer would be making those decisions themselves, like if they were using some other tool.
Hmm. Yeah, it does feel like optimizing for that and recognizing that, you know, Spark is almost like it's a Swiss Army knife, as you
Yeah,
mentioned. You can do a
yeah,
million things with it, but sometimes you don't want to do a million things. You just want to do one thing, and you want it to be really easy to be able to
yeah.
do that one thing. I had a friend who worked at some enterprise, and he was talking about how Spark engineers have all the job security in the world because A, like you said, you need a lot of them, and B, it's hard stuff being able to work on that and getting really deep and knowing it and the ins and outs of it. So I can feel where you're coming from on that one.
Yeah, I mean, we basically integrated the compute engine with the storage, so developers don't have to think about it. Plug in like whatever storage you want. We support obviously like all the blob stores, and we support Quadrant and Postgres right now. Indexify in the future can even like have other storage engines. And now all an application developer needs to do is deploy this on AWS or GCP or whatever, right? Have enough compute, point it to like the storage systems, and then now build your application. You don't need to make any of the hard decisions, or
Mm.
build a distributed systems by bringing together like five different tools and spend like 5 months building the data layer. Focus on the application, build your agents.
So there is something else as we are winding down. I want to ask you one last thing, and if anyone has any questions, feel free to throw them in the chat. I am monitoring that also, but I am wondering about advice that you have for people that are building RAG-based applications, because I feel like you've probably seen quite a few out there in the wild. And so, what are some optimizations or some nice hacks that you've seen that have worked really well?
Yeah, so I think, first of all, there is a recent paper, like a RAG survey paper. I really like it. Maybe you can have like the link on the show notes if
Yeah.
you have one. There was a recent survey paper. I really liked it, and it covers like a lot of tips and tricks for that people can use with RAG. But essentially, like RAG is an information. RAG is like a two-step process, right? In its essence.
Mm.
One is the document selection process and the document reading process. Document selection is how do you retrieve the most important information out of, like, million documents that might be there. And then the reading process is, how do you jam them in the context of a model, and so that the model can kind of like ground its generation based on the context. So I think the most tricky part here, and the part which has the most tips and tricks, is the document selection part, and that is like a classic information retrieval problem. So I would suggest like people doing a lot of experimentation around ranking algorithms, hitting different type of indexes, and refining like the results by merging results from different indexes. Um, One thing that always works for me is reducing the search space of the documents that I am selecting
Mhm.
in a very systematic manner. So like using some kind of like hybrid search, like where someone does the embedding lookup first and then does the keyword lookup, or vice versa, or like does lookups parallelly and then merges results together. Those kind of things where the search space is narrowed down, like always works for me.
So I think one of the Quadrant team members would love to know, because I've been talking to them quite frequently about this, the evaluating of retrieval. Have you found any tricks or tips around that and evaluating the quality of what is retrieved?
So I don't think there is a, I haven't come across like a golden like a one trick that fits every use case type
Mm-hmm.
thing, like solution for evaluation. Evaluation is like really hard. There are open source projects like Ragas,
Mm-hmm.
like who are trying to like solve it. And like there, everyone is trying to solve various aspects of evaluating like RAG.
Exactly.
Some of them try to evaluate how accurate the results are. Some people are trying to evaluate like how diverse the answers are, and so on. I think the most important thing that our design partners care about is factual accuracy.
Mm-hmm.
And factual accuracy, like one process that has worked really well is like having a critique model. So let the generation model generate some data, and then like have a critique model like go and try to like find citations and look up like how accurate the data is, how accurate the generation is, and then feed that back into the system. One another thing, like going back to the previous point, is
Mm-hmm.
what tricks, like can someone use for doing RAG really well. I feel like people don't fine tune embedding models that much. I think if people are using an embedding model like sentence transformer or anything like off the shelf, they should look into fine tuning the embedding models on their data set that they are embedding. And
Mm-hmm.
I think uh, a combination of fine tuning the embedding models and kind of like doing some factual accuracy checks lead to a long way in getting like RAG working really well.
Yeah, it's an interesting one, and I'll probably leave it here. It on the extra model that is basically checking factual accuracy. You've always got these trade-offs that you're playing with, right? And one of the trade-offs is going to be maybe you're making another LLM call, which could be more
100%.
costly, but you're gaining trust, or you're gaining confidence that what it's outputting is actually what it says it is, and it's actually factually correct, as you said. So it's like, what price can you put on trust? And we're going back to that whole thing that I saw on Chevy's website where they were saying that a Tesla's better. It's like that hopefully doesn't happen anymore. as people deploy this stuff and they recognize that humans are cunning when it comes to playing around with chatbots. So this has been fascinating, man. I appreciate you coming on here and chatting me with it. I encourage everyone to go and either reach out to you on LinkedIn. I know you are on there, and we'll leave a link to your LinkedIn in the chat too. And if not, like, check out Tensorlake, check out Indexify, and we will be in touch, man. This was great.
Yeah, same. It was really great chatting with you about this, Dimitros, and thanks for having me today.
Cheers. I'll talk to you later.
Later.